How to avoid having class data shared among instances. What I want is this behavior. Of course, what really happens when I print is clearly they are sharing the data in class A. How do I get separate instances to achieve the behavior I desire?
You want this. Declaring the variables inside the class declaration makes them class members and not instance members. Declaring them inside the _init_ method makes sure that a new instance of the members is created alongside every new instance of the object, which is the behavior you're looking for.
The accepted answer works, but a little more explanation does not hurt. Class attributes do not become instance attributes when an instance is created. They become instance attributes when a value is assigned to them. In the original code, no value is assigned to list attribute after instantiation, so it remains a class attribute. Defining list inside _init_ works because _init_ is called after instantiation. Alternatively, this code would also produce the desired output. However, a confusing scenario in the question will never happen to immutable objects such as numbers and strings, because their value cannot be changed without assignment. For example, a code similar to the original with string attribute type works without any problem. So to summarize, class attributes become instance attributes if and only if a value is assigned to them after instantiation, being in the _init_ method or not. This is a good thing because this way you can have static attributes if you never assign a value to an attribute after instantiation.
Although the accepted onware is spot on, I would like to add a bit description. Let's do a small exercise. First of all, define a class as follows. So what do we have here? We have a very simple class which has an attribute temp, which is a string, an _init_ method which sets self.x, a change method sets self.temp. Pretty straightforward so far, yeah. Now let's start playing around with this class. Let's initialize this class first. Now do the following. Well, a .temp worked as expected, but how the hell did a .temp work? Well, it worked because temp is a class attribute. Everything in Python is an object. Here A is also an object of class type. Thus the attribute temp is an attribute held by the class, and if you change the value of temp through A, and not through an instance of A, the changed value is going to be reflected in all the instance of a class. Let's go ahead and do that. Interesting, isn't it? And note that it.temp and it.temp are still the same. Any Python object is automatically given a _dict_ attribute, which contains its list of attributes. Let's investigate what this dictionary contains for our example objects. Note that temp attribute is listed among a class's attributes while x is listed for the instance. So how come that we get a defined value of a .temp if it is not even listed for the instance A? Well, that's the magic of _getAttribute_ method. In Python, the dotted syntax automatically invokes this method, so when we write a .temp, Python executes a ._getAttribute_temp. That method performs the attribute lookup action, i.e. finds the value of the attribute by looking in different places. The standard implementation of _getAttribute_ searches first the internal dictionary, dict, of an object, then the type of the object itself. In this case, a ._getAttribute_temp executes first a ._dict_temp, and then a ._class_dot_dict_temp. Okay, now let's use our change method. Well, now that we have used self, print a .temp gives us a different value from print a .temp. Now if we compare it a .temp and it a .temp, they will be different.
You declared list as a class-level property and not instance-level property. In order to have properties scoped at the instance level, you need to initialize them through referencing with the self parameter in the _init_ method, or elsewhere depending on the situation. You don't strictly have to initialize the instance properties in the _init_ method, but it makes for easier understanding.
If you want to learn more, perhaps a computer book reading.